this video, we're doing some really simple equation solving. And when it comes to solving equations, there's a couple really important things you need to remember. One is the set of inverse operations. So what we need to know is that addition and subtraction are inverse operations of each other. So if you add something and then you subtract it back out, you haven't done anything to the original value because the subtraction cancels out the addition. These are inverse operations of one another. If I start with 7 and I subtract 3, and then I add 3 back in, subtracting 3, and then adding 3 gives me 0. So I just get back to my original value of 7. So again, addition and subtraction are inverse operations. In the same way, multiplication and division are inverse operations of each other. So if I start with 5 and I multiply by 2, I get to 10. Then if I divide by 2, I get back to 5. So the division of the same number cancels out the multiplication of that number. So same thing if I start with division and then I do multiplication of the same number, I'm going to get back to the original value. Multiplication and division are inverse operations. We're going to use this concept a lot when it comes to solving equations. And then the other thing we need to know is our identity number properties, which is that 0 is the identity number for addition and subtraction, and 1 is the identity number for multiplication and division. And what we mean by the identity number is the number that doesn't change the identity. So x plus 0 is still x, which means that when we add 0 to something or subtract 0 from something, the original value doesn't change. So no matter what I'm adding 0 to, I'm not going to affect the value. So 0 is the identity number for addition and subtraction. Same thing here with multiplication. 1 is the identity number for multiplication. If I multiply something by 1, I still end up with that original value. So x times 1 is still x. Multiplying by 1 or dividing by 1 doesn't change the original value. So let's see how we can apply these concepts to basic equation solving. I have 4 equations here with addition, subtraction, multiplication, and division. So here I have x plus 3 equals 6, and I want to solve for x. Solving for x means I need to get x by itself on one side of the equal sign. So x is over here on the left-hand side of the equal sign. I can leave it there, but in order to solve for x, I need to get rid of the positive 3 that's over here on the left side with the x. So I have addition. I want to do the inverse operation, which I know is subtraction. So adding 3, I want to subtract 3. But remember, when we're dealing with equation solving, we always have to keep both sides of the equation balanced. So if I subtract 3 from the left-hand side, I have to also subtract 3 from the right-hand side in order to keep the equation balanced. Whatever I do on one side of the equal sign, I always have to do on the other side of the equal sign. So we're subtracting 3 from both sides, and let's see what we get. We bring everything down. So x comes down here. I have a positive 3 and a negative 3. Those two things are going to cancel. Or in other words, positive 3 minus 3, or 3 minus 3 gives me 0. So I can go ahead and say plus 0. And then I bring down my equal sign, and I have 6 minus 3. 6 minus 3 is 3. Now I go over to my identity numbers. I know 0 is the identity number for addition or subtraction. Adding 0 to something doesn't change its value. So x plus 0 is still x, which means I end up with x is equal to 3. So that's going to be my solution to this problem. The only thing I need to do now is confirm that x equals 3 is in fact a solution to my original equation. We all make mistakes, so it's really important to double check yourself. The way you double check yourself is by plugging this value back into the original equation. So the original equation was x plus 3 equals 6. I found that x was equal to 3, so I want to plug that back in. So instead of x here, I'm going to plug in 3. So I'm going to say 3 plus 3 equals 6. On the left-hand side, 3 plus 3, I know I get 6 there. So I get 6 equals 6, and I can say that this equation is true. It balances, which means that x equals 3 is a real solution to this equation. Let's look at a second example here. We have subtraction. We have x minus 3 equals 6. Well, I need to get x by itself, but right now I have x minus 3. So I have to get rid of that negative 3. I have subtraction, and I know that the inverse operation of subtraction is addition. So I have a minus 3, I want to do a plus 3, but everything I do to one side I have to do to the other, so I have to add 3 over here as well. Now I bring down my x, I have a negative 3 and a positive 3, that's going to be 0, so I'm going to say plus 0. Over on the right, 6 plus 3 is 9. 0 is the identity number for addition and subtraction. X plus 0 is still x. 0 doesn't change the identity of x, so I'm going to get x is equal to 9. So x equals 9 is the solution that satisfies my equation, but I want to double check myself. Plugging x equals 9 back into my original equation here for x, I'm going to get 9 minus 3 equals 6. 9 minus 3 I know is 6, so I get 6 equals 6, and that also checks out. Let's look at an example with multiplication. I have 3 times x equals 6, so I have multiplication. I know that the inverse operation is division, so I need to do division in order to try to get x by itself. So I'm going to divide both sides of the equation by 3, because if I'm going to do it to the left-hand side, I have to do it to the right-hand side. Now I'm going to get my 3's to cancel because I have 3 divided by 3. Well, we know that 3 divided by 3 is 1. So this is essentially 1 times x equals 6 over 3, which is 2. 6 divided by 3 is 2. 1 times x, this goes back to my identity number property. 1 is the identity number for multiplication and division. In other words, if I multiply something by 1, it doesn't change the value. X times 1 is still x, so multiplying by 1 doesn't change the identity of x. So on the left-hand side, I still have x, and on the right-hand side, I have 2. So I think that x equals 2 is going to be my solution, but let me double check myself. I'm going to plug x equals 2 back into my original equation. I had 3 times x equals 6, so instead I'm going to say 3 times 2 equals 6. 3 times 2 is 6, so I get this equation to balance, and I know x equals 2 is my solution. Looking at our last example, we have division here. We have x divided by 3 equals 6, or x over 3 equals 6. I'm doing division, which means I need to do the inverse operation of multiplication. So I want to multiply my left-hand side by 3 in order to try to get these 3's to cancel so I can solve for x. But since I'm multiplying the left-hand side by 3, I also have to multiply the right-hand side by 3. Now I can simplify. So here I'm going to get my 3's to cancel. I have 3 in the numerator and 3 in the denominator. Those are going to cancel with each other. Really, it's just going to be 1 times x. And on the right-hand side, I have 6 times 3, which I know is 18. Again, 1 is the identity number for multiplication and division. Multiplying x by 1 doesn't change the identity of x. So I still end up with x on the left, and on the right, I have 18. So I think x equals 18 is going to be my solution, but let's double check. Plugging 18 back into the original equation, which was x over 3 equals 6, I'm going to get 18 over 3 equals 6. 18 divided by 3 is 6, so I get 6 equals 6, and that checks out. So I know that my solution is correct, and that's how you use inverse operations in this concept of the identity number to just do basic equation solving.